At our Customer Engineering Resource Center in San Jose, California, you can easily evaluate and test Fujipoly products to see how they will perform for your specific application.
The most common test we do is this ASTM standard test. We start off with a given sample, whatever thickness. They can range from 0.5 millimeter, 5 millimeters, 7 millimeters, whatever really needs to be tested. And you place it in this standard, it's about 28.6 millimeter diameter circle. And then the next thing we do is we set compression speed. So the compression speed is really critical. Go real slow, you're going to get less force. You go too fast, forces are going to increase. It's just the dampening material on the property. With this system, we can actually change speeds from as high as 100 millimeters a minute, and we can go as low as 1/10 of a millimeter a minute. So we can be able to give customers a pretty good broad range of speeds. Once we have that set up, once we have the speed set up, and we got the sample centered in here, the next thing we do is we go over to the software, and we actually set the conditions that we're going to test to. Primarily what we're looking at is how far are we going to go till we stop, right? So for a 1.5 millimeter material, in this case, we decided to take this down to what we thought was about the max compression that we would want to work with, which is about a 0.3 millimeter gap. The other piece of detail that customers want to know is how the material is going to relax over time. So we know from our own experience of these putty materials, and it's most of the GR materials in general, after about a minute, you see from that T0, when you stop, down to about 1 minute, you see a sharp drop in the stress, and then it starts to kind of bottom out. So we also look at that as well. So we give the customers basically a curve for a stress strain curve at a specific speed, and then what we'll do is we'll actually wait 1 minute, and then you get this force here at 1 minute. So basically, it gives you the dynamic forces that you're dealing with, and then the static load you're going to see in the pseudo-static load you're going to see in the, I call it pseudo because it actually does change a little bit over time.